Today we are going to discuss questions related to center of mass, where we'll calculate the center of mass of the remaining part, center of mass of continuous bodies, then for point masses or extended bodies, and the final thing that we are going to see for 2D or laminar shaped objects. So first, for center of mass of remaining part. Suppose they have given an entire circle which is of radius 4r and a smaller circle which is said to be cut out of the larger part of radius smaller. So they are asking what is the center of mass of this remaining portion which will remain after removing the cut out part. First we will do two things. First we will find the area, and second we will find the coordinates. First we will write for the larger circle and second for the smaller circle. For the larger circle they have given the radius, so area would be pi into 4r the whole square. For smaller it will be pi into r the whole square. Then the coordinates. For larger circle the coordinates we basically take it as 0, 0. This is the origin for the larger circle, 0, 0. For the smaller circle we take with respect to this origin, that is this is 0, 0. We can find out that this is 2r. Okay, this entirely is 2r and this entirely is given as 4r. Then what would be the coordinates of this point? It would basically be on x-axis it is 3r. Okay, see this is 2r and this is r, so total it is 3r, comma on y-axis it is still on the original point, so it is 3r, 0. So coordinates of the smaller is 3r, 0, while for larger it is 0, 0. Now the next thing that we have to find is using the formula, that is xcm, which is x1a1 minus x2a2 upon a1 minus a2. Now what is x1? The larger one we are giving as x1, this is y1, this is x2, this is y2. Now substituting x1 in the formula, this is 0 multiplied by a1 will also be whatever the value of a1, that is pi into 4r square, it would be 0. x2 is 3r multiplied by pi r square divided by a1 minus a2, which will be 15 pi r square. This will entirely be 0. Okay, pi r square would cancel out. The answer would be minus r by 5 centimeter. If unit is not given, we did not mention. So minus r by 5 indicates it is towards the left hand side, that is over here. Okay, minus. If we try to find YCM, we see y1 is also 0, y2 is also 0. So here y1 a1 which we would write would be 0 minus y2 a2. This term would also come to be 0. And here a1 minus a2. So this is of no use. Directly we get the answer as 0. So the center of mass which is there of the remaining part shifts at minus r by 5, 0. Okay, there is no change in the coordinates of the y-axis, only the change is seen in the x-axis. The second is for non-uniform mass distribution present on the rod. There are two types of questions seen over here. First is where lambda is standing for mass per unit length. When this varies directly to x to the power 1, okay, there is no other term over here, then the direct formula used for finding xcm will be 2l by 3, provided that l is taken from the point which we consider as 0, 0 till the end point. Okay, that is the l. So this is entirely the l. Second case is where it is not directly proportional to x, rather there is an intermediate term here, alpha given. Okay, over here we have to go through the longer method. First we saw that lambda is nothing but mass upon length, right? We write as dm by dx. So what we find out through this equation is that dm is equivalent to lambda dx. We mark this as equation number 1 because it's going to be useful. Later on, there is the formula which we need to always remember for finding xcm of non-uniform mass distribution. It is integration of dmx upon integration of dm. Instead of dm, we substitute this value, okay, that is integration of lambda, okay, x dx divided by integration of lambda dx. The value of lambda is given to us, so taking this xcm part, we'll continue over here. Xcm will be integration of alpha plus beta x, okay, instead of lambda we wrote this, and then remaining thing we write as it is, that is x dx, okay, and we divide it by integral of again alpha plus beta x, that is lambda, multiplied by dx. Then we try to open up the bracket, that is alpha x dx, okay, be integrated separately, beta x square dx, again we integrate it separately. In the denominator, similar thing happens, integration of alpha dx plus integration of beta x dx. Your basic integration is going to be used, so we are just going to integrate. xcm will be equivalent to, so integration alpha would be constant, it comes out, so integration of x dx would be x square divided by 2, so we'll write alpha x square divided by 2 plus integration of x square dx would be beta x cube divided by 3. In the denominator we get alpha x plus beta x square divided by 2. Then when we later on solve it, finally we get the solution, okay. One more thing is, here we integrated from 0 to L because the entire rod is said to be integrated, right? So here from 0 to L, we take the limits. Instead of x, everywhere we try to put L, okay, first, and then we subtract, and then we put 0. So 0 has no value, so only L we'll substitute, and we would get the solution as L by 3, 2 alpha, 3 alpha plus 2 beta L, okay, 3 alpha plus 2 beta L divided by 2 alpha plus beta L. So this is the solution of the entire question, where non-uniform mass distribution of the rod questions were solved. The next question is center of mass for point masses, okay. Suppose there are 2 points which are given on a coordinate axis. One point has a mass of 1 kg, another has a point mass of 2 kg. We mark first and foremost the coordinates x1, y1, and the second one we give it as x2, y2. Now nothing, just the formula. xcm formula which is there, it is m1 x1 plus m2 x2 divided by m1 plus m2. Now m1 for value which is there, we'll consider this as m1 and this as m2. Write 1, okay, multiplied by x1, that is minus 1, plus m2 is 2 multiplied by 2 divided by sum of their masses, that is 3 kg. Similarly for ycm, m1 y1 plus m2 y2 upon m1 plus m2. Here we get denominator as 3 again. Numerator we write it as 1 multiplied by 2 plus mass of m2 is nothing but 2 multiplied by y2 is 4. On substituting all the values, we get xcm as 1 and ycm we get as 10 by 3. So these are the coordinates of the center of mass for point masses. The next question is, this is also center of mass for point masses itself, okay. Here also coordinates first we'll mark. This is 0, 0. This is 1 meter. This is also 1 meter because it is an equilateral triangle, okay. So this coordinates of this kg, this 2 kg mass is nothing but on x-axis it is moving 1 meter, on y-axis it is 0. The coordinates of this mass, okay, we need to find out. First we'll try to draw a line which is perpendicular. Okay, so it's making an angle 90 degree. We know this angle is 60 degree because it is an equilateral triangle. The angles of the triangle are 60 degree. Then we'll directly try to formulate that this distance is half meter. Okay, now we'll directly try to find out that what is the length of this side. Okay, we know by Pythagoras that 1 meter is given, half meter is given, so this side could be found out. So 1 square will be equivalent to half square plus the length of this we'll consider as x. Okay, or we'll consider this letter as z. We need to find z square. When we solve this, we get the value of z, okay, as root 3 by 2. So we get that on x-axis 2 kg is at half, okay, and on y-axis it is z. Z is equivalent to root 3 by 2. So we got all the coordinates, okay, as earlier question itself. Now the thing basically we need to do is x1, y1 we need to mark, x2, y2 and x3, y3. Then for xcm we need to find. Xcm is m1, x1 plus m2, x2 plus m3, x3 divided by m1 plus m2 plus m3. Add up all of those values by putting individually. Okay, if we are taking this as x1 and this is y1, so this is m1. Okay, similarly this is m2 and this is m3. By substituting the values we can find xcm as well as ycm. Okay, ycm we get root 3 by 4 and xcm we get 7 by 12 meters. So this was the questions based on point masses. Now center of mass of extended bodies. When there were point masses, the coordinates were easily known to us, okay, by the coordinate system. Over here they have given this point as 0, 0. We know that this is a long rod. The center of mass of this individual rod would lie on its center. For this rod it would be over here, and for this rod it would be over here. So on the basis of the origin we mark these 3 points coordinates. So this is at a distance. See, length of each rod is given as L. Okay, so this distance would be L by 2, and on y-axis it is not going up. Okay, so it is 0. Then coordinates of this point. This point is 0 in case of x-axis, but on y-axis it is at a distance L by 2. This point again, if we see, on x-axis it is at a distance L by 2. On y-axis, with respect to the origin, it is at a distance L. Okay, length of each rod is said to be given as L. After that we'll see that to find the xcm, the formula here is m1 x1, again similarly m2 x2 till m3 x3, because there are 3 rods, divided by m1 plus m2 plus m3. Here we see that basically we give this as x1 y1, so this is x1, substitute here x1. Similarly this is x2 y2 and x3 y3. Rest all remains the same. We just have to substitute x1 as L by 2, x2 as 0 and x3 as L by 2. What will we keep the masses? Since these rods are identical, each mass we would keep as m1 equivalent to m2 equivalent to m3, which will be given as a common letter m. And when we solve this question, okay, by putting all the values, we get xcm, okay, as L by 3 and ycm we get as L by 2. So in the cases of rods or any extended body, first we try to find the center of mass of that individual part. Then we give a coordinate to that point, okay, with respect to the reference. What reference we are taking, this would be already given in the question, so we need not worry. After that, center of mass for laminar or 2D objects. Two-dimensional object center of mass we can find out by similar manner where we saw for the extended rod case. First individual object we see where its center of mass lies. So for this square part, the center of mass lies over here, and for this rectangular part, it lies over here. Okay. Now we have to give the coordinates with respect to the origin, that is 0, 0. So the side which is there, length of the side is 2 meters. Okay, so this distance would be 1 on x-axis, and on y-axis it is moving how much up? So it is moving, if we look at the symmetry, agar this is 1 meter, then this would be half of meter. Okay, so this is half. Similarly, center of this is at a distance how much? See, this would be entirely 1. Okay, and this is not entirely 1, this is half. Okay, so this entire distance would be 1 plus half. When we add them up, we find that we get 3 by 2. And this distance which is there on x-axis, it is said to be at 1 by 2. Okay, on x-axis it is 1 by 2, on y-axis it is 3 by 2, because this is lengthwise y and this is x. So we got x1, y1, x2, y2. Now we might consider that m1, x1, again we are going to do the same thing, but for laminar objects we consider their area rather than the mass. Okay, so we'll do x1 a1 plus x2 a2 divided by x1 plus x2. So what is the area of rectangle? This is area, this is a1, which will be equivalent to 1 multiplied by 2, that is length into breadth, and area of a square is side square. So a2 will be equivalent to 1 into 1. So we got a1, we got a2, we have x1 and x2 as well. When we substitute, denominator we add a1 plus a2. When we substitute these values, we find xcm as 5 by 6 and ycm as also 5 by 6. So these were the questions which were mainly seen. There is also one more type of question. Suppose there is carbon kept over here and oxygen on the other end. Okay, and they are asking the distance between these two is L. Okay, and they are asking that tell us the center of mass from carbon, where does it lie? Okay, with respect to these two, center of mass from carbon. So center of mass from carbon will be equivalent to mass of oxygen divided by mass of oxygen plus mass of carbon multiplied by the distance between them. So from where we have to find the center of mass? From carbon. So the numerator would contain mass of oxygen. So the opposite thing happens over here. So this is the way in which we try to solve all the center of mass questions and all related topics.